This is a video about using SPSS to conduct repeated measures analysis of variance. In this case, we are going to examine the relationship of time and family risk in explaining differences in Peabody Picture Vocabulary test scores. They are the Roche-Wright scores, so they are a type of scale score. The Roche-Wright scores are for kindergarten, first, second, and third grade. And family risk is the level of risk that's associated with family characteristics. So these are child scores tied into family risk variables. And we're wanting to see whether there is an interaction between time and family risk in explaining the differences in these PPVT Roche-Wright scores across these 4 grade levels. To do that, we go to Analyze, General Linear Model, Repeated Measures. Our within subjects factor, which is our repeated measure, we're going to call time, and we'll have 4 levels because we have 4 grade levels. Click Add, and we get down here and we click Define. That will take us to the repeated measures ANOVA screen, and we just put in order of time our repeated measures variables. These are our 4 PPVT variables. These are our 4 dependent variables. It's the same instrument across time. So we want to make sure that they are in the order. So we have 4 of them. So this first one is actually kindergarten, first grade, second grade, and third grade. Our between subjects factor is family risk. So we send that down there. We need to make sure that we have not changed our model. In a previous video, I had done ANOVA, so we need to make sure that the model is still the full factorial model with type 3 sums of squares. It is, so we can continue there. We are going to go to plots, and this is going to show us the actual nature of the interaction between time and family risk. So we want time along the horizontal axis, and we want separate lines for family risk. So we identify those and we send them down here by clicking Add. You need to make sure you click Add or you won't ever see your plot. Click Continue. We're going to go to Options. We're going to make sure that we ask for all 3 of these to go over here to Display Means so we can get the main effect comparisons. This is essentially going to give us the least significant difference post hoc tests without us having to ask for them as a separate test. We're also going to ask for descriptive statistics, estimates of effect size, and homogeneity tests. You can ask for others, but in terms of a basic run, those are the 3 that we really need. We click Continue, and we can click OK. And we get our outputs. You see that we have 30 subjects, and these are subjects with complete data. Okay, so we have 30 subjects with family risk level of 0 across all of those grades. We have 247 at level 1, 386 at level 2, 243 at level 3, and 47 at level 4. We can come down here and we can get an idea of what the relationships look like. You can see that it looks like the lower the level of family risk in general, the higher the means are across each one of these grade levels. So we might be anticipating a relationship in which there is an effect for family risk, but it looks like those patterns are pretty stable across time. So while we might expect a time effect for the PPVT, we might not see an interaction between the time variable and the family risk variable, because it looks like the patterns are stable across time, which means that they will be parallel. The interaction effect between time and family risk is essentially a test of whether or not the differences that occur in the PPBT for family risk levels are parallel across the different years of time. The box M test is the homogeneity of variance covariance matrices. It is very sensitive. This indicates that we have rejected that assumption. We're going to proceed anyways. We know that this procedure is very sensitive, and there are ways in which we can address it, but we're going to we're going to ignore it for this example. So the area that we're going to attend to, we're going to skip the multivariate interpretation. The Wilks lambda is basically telling us that that time is explaining about 73% of the variance, and it looks like there's very little interaction between time and family risk, which is kind of what we expected. We're going to go down and we're going to look at more at the univariate approach. We're going to look at this. First of all, we're going to look at this Mauchly's test of sphericity. So the test of sphericity, we're not looking at the traditional homogeneity of variance problem. One of the assumptions that we have, since we have repeated measures with these subjects, there is this assumption that has to be met, that essentially that the variance covariance matrices across time are stable, which means that the correlations between time 1 and time 2 and time 1 and time 3 and time 1 and time 4 essentially have to be equivalent, or that the correlations of those different scores have to be equivalent. That's very difficult for us to achieve. So whenever you have more than pre-test and post-test, whenever you have more than 2 time periods, you need to look at this Mauchly's test of sphericity, and very often it will be rejected, in which case we will tend to use one of these 2 corrections, the Greenhouse-Geiser or the Heinfeld. For our purposes today, we're going to use the Heinfeld procedure, and we're going to go, the Greenhouse-Geiser. We're going to come down here and we're going to look at these results. Okay, so what we see is when we look at the Greenhouse-Geiser adjustment, which is made based on the information up here with this Mauchly's variable right here, and the epsilons are tied to this. So we go down here, we look at this Greenhouse-Geiser, and what we see is that indeed there is a time effect, and that time appears to account for about 55% of the variance, the unique variance, and the interaction between time and family risk is not significant. And so the interaction that we are seeing here could have occurred due to random sampling fluctuation alone, when the null hypothesis was true about 22 times out of 100. Okay, so we don't think that this effect is statistically significant. So we're not going to reject the null hypothesis of parallelism. So we believe that those lines are going to be parallel, and you can see that it only explains very, very little variance, unique variance. So then we're going to go down here and we're going to look to see whether or not the effect that we saw for time was linear or nonlinear. And what we see is that the effects are cubic, quadratic, and linear. So because we have 4 time periods, we can look at whether, so if we only had 2 time periods, we would only be able to determine whether or not there's a linear relationship. If we had 3, we can determine if there is a single curve that helps explain it, and that would be a quadratic effect. Because we have 4 time periods, we can be looking for 2 curves, which would be a cubic effect. In this case, we find that we have linear, quadratic, and cubic effects. We tend to assign the relationship to the highest order of the polynomial. So in this case, it's going to be 0.000 here, which is a cubic effect. So since we have a significant cubic effect, we're going to describe this relationship as cubic. We see that the partial eta squared for that cubic effect is fairly small, about 5% of variance, but we see that all of those effects are equivalent, are significant. And again, while we find there to be a significant quadratic effect, we found no overall effect. So it's probably inappropriate for us to interpret or overinterpret this quadratic effect in terms of that interaction. For our effect for family risk, we find that level of family risk does matter in terms of the average of the PPBT scores across time. So this test is a test of whether or not the average PPBT scores across time are different for different levels of family risk. That answer is yes. So we're only explaining about 8.5% of the variance in the PPBT scores by family risk, but that effect is statistically significant. For our purposes, we'll skip the interpretation of these marginal means, but one of the things we could look at is you can see that there's been an adjustment. So if we look at the family risk here, we can see that these levels of means across time, these means across levels of family risk do tend to drop. It looks like they're dropping almost linearly as we go down. The pairwise comparisons help us determine where those significant differences are, and we can see that we have significant differences for essentially for all comparisons except for the comparison between family risk level 0 and family risk level 1. There's no statistically significant difference between those, between the average PPBT scores for those levels of family risk, but there are for all others. Scroll down. We look at the effects for time. And again, we see that all time variables, all the average of PPBTs across family risk levels are different for each time. That is, they are, if we subtract level 4 from level 1, that means that time 4, third grade from kindergarten, we see that there is a gain. We expect these gains. This is not like comparing standard scores across time. These are Ross-Wright scale scores. We expect them to increase across time. So we see this increase here. We see that the difference between time 4 and time 3, third grade and second grade, is not as great as it is between a third grade and kindergarten, which is what we would expect from these scores. We see the interaction effects, and again, there's not going to be any significant interaction. So we're going to look at the profile plot, and again, the interaction effect, the interaction test for a repeated measures design when we're looking at an interaction between time and one or more independent variables is a question of whether or not the lines, the slopes, are parallel across time. And this is as clean an indication of parallelism as you will typically see in repeated measures ANOVA. So this confirms, this validates, and it displays that lack of interaction or the evidence of parallelism. So it's basically saying that regardless of your level of family risk, your scores are going to increase across time, that having higher family risk does not cause a significant break. You start lower and you finish lower, whereas those with low family risk start higher and finish higher. There is no interaction, there's no crossing of these slopes as we look changes across time. So that is the overview of the interpretation and running of an SPSS repeated measures ANOVA. Thank you.